This video is going to go over the filling out this table, which is meant to help you understand the formula for the Pearson's R correlation. So we're just gonna fill out this table and then fill out the formulas here at the bottom and come up with our regression equation as well. So the first thing that you should do when you get any math assignment or worksheet or anything like that is just kind of look it over and see what you're going to have to do. So we can see here that it says correlation and regression, right? So that's what we're going to be working on. Our table has a number of columns. It has this kind of thicker column which says scores. That's subdivided into an X and a Y column. And you can see that we have the points here. So these are just X and Y coordinates. Like we can fill these, we can do a scatter plot with these and, on an X and Y axis, and then draw a line that would best fit that pattern. Then we have this other column here, deviations, which is made up of two subcolumns, an X minus an M subscript X column, and then the column that is a Y minus M subscript Y. So these M's they're the means for the respective columns, and you can see down here on the worksheet that we have a respective M subscript X and M subscript Y, which implies that you are to add these scores in the X column and then find their average and get that, put that here. Similarly, you would do the same for the Y's, add those and find their average, put that here. And then there's a square deviations column, which is subdivided into two subcolumns. One of them is X minus M subscript X squared, and that's simply just this, the X minus M subscript from the deviations column. So here, this column is asking us to take the numbers in this column and square them. Similarly, this column is asking us to do the same thing with the Y minus M subscript Y deviations here. So the square deviations, we're just going to square these deviations columns. And then lastly, we have this products columns, which is, again, we see this X minus M subscript X and the Y minus subscript Y. And we're just multiplying those two things. So those are the deviations, right? They're the respective deviations. So for that last column, we're multiplying these two together. And you can see that we have summations at the bottom of these columns. So we are going to sum downward across these columns to give you the sum of squares X, sum of squares Y, and the sum of products here. And those components are the necessary parts that we need to fill out the formula for the R Pearson correlation and to get the slope and the y-intercept for the regression equation for the line. So for this, I'm not going to calculate things on the spot. What I'm going to do is just fill in every cell, but be telling you what other column I'm operating on to fill that in. But I am just going to go cell by cell filling these in. So this will kind of help you to check your work as well, to see whether you're going through the right kind of mental process. Okay, so I angled the camera so that we can fit the whole table in. Okay, and we're just going to start filling them out. So the first thing that we need to do is we got to get these averages, because we're going to have to use them to subtract the values from, the X and Y values from. So I already calculated this, and when you get all the X's and find their average, you get 3.1. And when you average out all the Y values, you get 10.3. Okay, so now for the deviations, what I'm going to do is I'm going to take this average that we found and subtract that from all of these X values. And I'm going to fill in each cell in this column here. So I'm just going to go, I'll try not to go too fast, but I don't want to take too much time. So we're gonna do one minus 3.1, and that gives us negative 2.1. 3 minus 3.1, that gives us negative 0.1. Let me angle that better. Then we're going to do 2 minus 3.1, and that'll give us negative 1.1. Then 3 minus 3.1 again, and that gives us negative 0.1 again. Then we do 5 minus 3.1, and we get 1.9. Then we do 4 minus 3.1, and we get 0.9. And then we do 5 minus 3.1 again, and we get 1.9 again. Then we do 2 minus 3.1 again, and again we get negative 1.1. We have 4 minus 3.1, so we get 0.9 again, and then lastly we have 2 minus 3.1, and again we get negative 1.1. So we're going to go through this exact same process of subtracting the y mean of 10.3 from all of the y values and fill in these cells here. Okay, so we have 3 minus 10.3 gives us negative 7.3. 10 minus 10.3 gives us negative 0.3. 7 minus 10.3 gives us negative 3.3. 11 minus 10.3 gives us 0.7. 19 minus 10.3 gives us 8.7. 17 minus 10.3 gives us 6.7. Again, 17 minus 10.3 gives us 6.7. 4 minus 10.3 gives us negative 6.3. 12 minus 10.3 gives us 1.7. 3 minus 10.3 gives us negative 7.3. Okay, so now we're going to fill out the square deviations column. That is just telling us to take this column here for the x's and square all these numbers, fill in these respective cells here, and then for this one we're going to square these y values and fill these out. Okay, so let's get started with that. First with the x's columns. Negative 2.1 squared is 4.41. Negative 0.1 squared is 0.01. Negative 1.1 squared is 1.21. Negative 0.1 squared again is 0.01. 1.9 squared is 3.61. 0.9 squared is 0.81. 1.9 squared again is 3.61. Negative 1.1 squared again is 1.21. 0.9 squared again is 0.81. And negative 1.1 squared is 1.21. So we're going to do the exact same thing now and square this column here, the y minus m subscript y columns. Negative 7.3 squared is 53.29. Negative 0.3 squared is 0.09. Negative 3.3 squared is 10.89. 0.7 squared is 0.49. 8.7 squared is 75.69. 6.7 squared is 44.89. Again, 6.7 squared is 44.89. Negative 6.3 squared is 39.69. 1.7 squared is 2.89, and negative 7.3 squared is 53.29. Okay, so now we have one more column to go. For this last one, we're just going to go to the deviations column and multiply the x deviations and the y deviations together. So let's go ahead and start. Negative 2.1 times negative 7.3 is 15.33. Negative 0.1 times negative 0.3 is 0.03. Negative 1.1 times negative 3.3 is 3.63. Negative 0.1 times 0.7 is negative 0.07. 1.9 times 8.7 is 16.53. 0.9 times 6.7 is 6.03. 1.9 times 6.7 is 12.73. Negative 1.1 times negative 6.3 is 6.93. 0.9 times 1.7 is 1.53. Negative 1.1 times negative 7.3 is 8.03. Okay, so we've done all the heavy work. Now the next thing would be to actually just sum these columns in order to get the totals for each column. So by summing the deviations from x from the respective x mean, we get the sum of squares x, and for that we get 16.9. Summing all of the deviations, the y deviations from the y mean, we get 326.1. And then lastly, summing up all the products of the deviations of the x and the y's from their means gives us 70.7. Okay, so now we can fill out this formula here and figure out what that correlation value is. So we have the sum of products here, that's 70.7. And we have the sum of the x's and the sum of y's. So we have 16.9 times 326.1. And I get 0.9523589. So 0.95. So for the slope, we have 70.7 over the sum of the x's, which is 16.9. And I get 4.18343, so about 4.18. And then now the a is our y-intercept. So we're gonna take the the average of the y values, which was 10.3, and then subtract from it the product of the slope, which is 4.18, and the average of the x's, which was 3.1. So I get negative 2.658, so about negative, yeah, we could just go with that, negative 2.658. So now we can figure out what our equation for our line is. So we have the slope here was 4.18, and our y-intercept is negative 2.658. So we could use this line to make predictions. The scatter plot in the line would look something like this. So you can see that that it's a pretty tight correlation. It ended up being, right, 0.95, right? So it's almost a perfect positive correlation. You can see that the values are not too spread out. They're not too far away from the prediction line. And this line can be used to make predictions about other values. So, yeah.